Hi there, in this video we're going to go through Activity 2 Series Resistors, Investigation number 2. Now once again, this activity was based on an every circuit interactive simulation, so make sure that you've got a copy of the activity sheet in front of you and that you also have a copy of the Every Circuit app on your mobile device or inside your Chrome browser. Once you have signed in to the application, you need to go to the community space and look for the circuit called NOC Series Resistors number 2. Now I'm going to interact with the Every Circuit app on a mobile device in this video. So I have already signed in to the Every Circuit app on my mobile device. I'm going to go to the community space. I'm going to press the search button and I'm going to search for NOC, underscore series resistors 2. Now in this case I only get one result up, and that is the result that I would like. So I'm going to open up that circuit over there. Okay, there it is. Now going back to the worksheet. It says we have the same circuit as before, so the same circuit as we had in the previous video, where we had a 12 volt voltage source and 3 resistors connected up in series, a 1 kilo ohm resistor, a 250 ohm resistor, and another 250 ohm resistor. So all of that is the same. But it says that, and that the current flowing through the circuit is still 8 amps. We can see that over there. But this time we have connected voltmeters across each of the resistors. So we can see the voltmeters over there. There's the 1 voltmeter registering a voltage. Here is another voltmeter registering another voltage. And here is the third voltmeter also registering a voltage. Now it asks us, what is the voltage across the 1 kilo ohm resistor? So let's have a look. Well, here's the 1 kilo ohm resistor, and we can see that the voltage across this resistor over here is given as 8 volts. We can see that in the kind of purple writing there above the voltmeter. So the voltage across the 1 kilo ohm resistor is 8 volts. What is the voltage across the 250 ohm resistors? Well, let's have a look. So this resistor here, this 250 ohm resistor, has a voltage across it of 2 volts. That's a voltage drop of 2 volts. And it's another voltage drop across the other 250 ohm resistor of a further 2 volts. Okay. Question number 3 asks us, what do you notice about the sum of the voltages across the resistors? Well, let's have a look. So we've got 8 volts across the 1 kilo ohm resistor. We've got 2 volts across the 250 ohm resistor, and also 2 volts across the other 250 ohm resistor. Now 8 plus 2 is 12, which is the same as the voltage source of the circuit. The battery in the cell in the circuit is providing 12 volts of voltage. So it seems that the voltage drop across each of the 3 resistors in the circuit is equal to the voltage being put into the circuit by the battery. And lastly, what do you notice about the voltage across each resistor and its resistance value? Well, the first thing we notice is that the voltage across the 250 ohm resistors is the same. So it seems that because their resistance values are the same, the voltage drop across them is also the same. And we can see that the voltage drop across the 1 kilo ohm resistor, that one over there, is greater than either of the other two. And this one is in fact 8 volts. Now what do you notice about the ratios? Can you see that the size of the resistor, the 1 kilo ohm resistor to the 250 ohm resistor as an example, the difference there is a factor of 4. The 1 kilo ohm resistor is 4 times bigger than the 250 ohm resistor. Does that match the size of the voltage drops? Well, I think it does. The voltage drop across the 1 kilo ohm resistor is 4 times bigger than the voltage drop across the 250 ohm resistor. Now we can do some calculations. We can divide the resistance of the resistor by the voltage drop across that resistor. So when we divide, for example, 1000 ohms by 8 volts, we get an answer of 125. When we do exactly the same calculation with one of the 250 ohm resistors, so 250 ohms divided by 2 volts, we also get 125. It looks like things are in the same ratio. So in other words, it is the ratio of the resistances is exactly the same proportion as the ratio of the voltage drops across those resistors. In this case, the difference is a factor of 4. The 1000 ohm resistor is 4 times bigger than the 250 ohm resistor, and so the voltage drop across the 1000 ohm resistor is also 4 times bigger than the voltage drop across the 250 ohm resistor. And so the ratios of the resistance values and the ratios of the voltage drops across those resistors are both in the ratio 4 to 1.